So, today we're going to talk about re-expressing data. So, re-expression is the process of applying a function to the data in order to make a scatter plot straighter, and then to apply a regression model, or to make a distribution more symmetrical. So there are three goals of re-expression. One, has already been mentioned, is to make the distribution of the data more symmetric. So Claire, think of taking notes as your opportunity to make your handwriting as beautiful as possible,
Oh, that's a good idea.
not as fast as possible.
You're gonna re-express that handwriting.
So for example, on this one, where we had CEOs and how much money they made, in this original data, it's not close to symmetric, right? And since it's not close to symmetric, will a normal model be any good at all for, approximating anything? No. But if we take the logarithm, and they do base 10 logarithms almost always of the pay and the number of CEOs. Notice this, although it may have an outlier over here, is way closer to symmetric, isn't it?
Yeah.
So a normal model is going to fit it much better than the other way around. So that's one of the things that you might want to re-express data. Yes?
Wouldn't that be like altering the distribution though? Would that not make it like observing it inaccurate compared to without taking the logarithm?
No, although I understand what you're saying. You're like, it feels like you're cheating, right? What you're doing is, sometimes this is called washing the data. And washing the data is not a bad thing. Throwing data points out because you don't like them, or because your political opponent agrees with that one or whatever, that's bad.
Yeah.
But washing the data, basically you're trying to make it fit to something that you could work with. You've treated every single point the same. Every single point we've taken the logarithm of their compensation. So it's fair to each one of them, and now we could apply a normal model. The whole deal is that you could theoretically come up with a right skewed model and a left skewed model, and you could come up with all these different models for different things, but it's easier to re-express the data so that you can use a normal model, or you can use a linear model for your data. That makes sense?
Yeah, that makes sense.
All right. On this second one, when you look at the first set of box plots, you really can't tell anything at all from these first ones, can you? Okay, so one of the other ones is to make the spread of several groups more alike. Even if the centers are different. So notice on this one what they did, there's only one, this is univariate data, right? This is no longer bivariate data. There's not two sets of numbers. By taking the logarithm of this, they've spread this out. So you can see, oh, okay, where the median is in this, you have no idea. But now you can see, okay, the median of this is in the bottom quartile of this one and would be an outlier for this one. Okay, so you can make comparisons. You can't make comparisons with this picture. Yes?
Is all the data from the first picture represented in the second picture?
Yep.
So when we re-express data, I guess my question is with the log, how does re-expressing it with a log change the amount of outliers?
Oh, so they're actually, because you're taking the logarithm of this, the logarithm knocks big numbers down to make them much smaller, and makes this so yeah, it will change. You're like, okay, I have these outliers. It won't show those this way.
Is that a concern when we're representing data?
It's not a concern when you're comparing them, right? So now I can compare the means, and I can compare the where the 25th percentile is, and the interquartile range and all those kinds of things. I can make that comparison, but I can't talk about specifics of just this one alone. Does that make sense?
Yeah.
All right. Well, this is going fast. Page 2. And this is the one that we're really concerned with here, is to make the form of a scatter plot more nearly linear. I'm going to practice making my lettering nicer too.
You're still really fast there, Claire. I noticed that your pencil stopped moving before the notes.
Hey, Shepard, let's keep our eyes around this.
No, I heard it. That's how I noticed. Why did you assume that I was gonna
Did you do one of those when you finished?
real loud?
So good to hear.
So you like a surgery absolutely interesting.
I know 3 times 4. No, that's real.
Yeah, and that at some point, I have to break some of my 7th graders of the I have to finish first to prove that I'm smarter, and I'm like, but you scored 15 points lower than this person.
Do you sit next to him and just do it all? Easy.
I try to have things keyed before I give it out. It does. I have done that before, where I've keyed something while people are taking it, and they're always like, "Oh gosh, you're done?" I'm like, "Yeah, it wasn't that hard." Okay, so notice on this one, you have this slight curve to this. You can't use a linear model for this and expect to make very good predictions. But notice that this sort of looks like a sideways parabola, yes?
Yeah, it could be.
Actually, it looks a lot like a sideways parabola. So then what they did is they squared the output so that these would all move up so that it looks less like a parabola. The fact is, that looks fairly straight.
I think we could draw a line.
Yeah.
Yes, let us see. Well. It isn't a line.
It's pretty good. All right. And then the other thing is to make the scatter in a plot spread out more evenly rather than thickening at one end, which is a problem. Remember, if the scatter plot kind of opens out, or it starts big and then it closes in, that's not good. Yes.
Yes, not good being bad. Yes.
All right. So what you have here beneath this line is something called the ladder of powers.
Oh goodness. This is where it gets bad. Mr. Ballard talking about this.
About the ladder of powers? He doesn't like statistics.
I remember
I hate scatter plots.
Yes, every day.
All right. So if it appears that your data may be helped by re-expression, try one. And here's the problem, is that this doesn't get tested directly on the AP exam very often. We'll talk more about what does get tested later, because if you try something, sometimes it doesn't help, and it takes a while to re-express all the data. Okay, so if you try something and it doesn't help, and you do that on my test, leave it and go, and then write a note. Yeah, I probably picked the wrong one because this didn't help as much as I wanted it to. Okay. So and I said I usually start with either a square root or a logarithm. If this helps but not enough, then move up. Move to the next level down. So you can square the data values. This helps for things that are skewed left, or scatter plots that look kind of like a square root value. So you're squaring the y values. That's what we did up here. We squared the y values. Because this looks like a square root function, it helps straighten it out some.
30 times 30.
Okay? That's about as extreme as we get. This one is no change at all.
I like that.
Okay? Notice here that data that can take on both positive and negative values with no bounds are unlikely to benefit from re-expression ever. So if you've got both positive and negative values, re-expression probably isn't going to help. We can take the square root of the data values. This can, this is usually best when you have counts. When you have counts of things, frequently the square root is helpful. You can take the log of y. Notice, because you can't take the log of a negative number, your y values have all got to be positive. If the data includes any zeros, one of the things you can do to kind of cheat this is add a small constant to all values before finding the logs. That way you're never taking the log of 0. This can help if the data is concave up. That meaning if it looks kind of like that. And then you get to ones that I almost never use unless the problem specifically states what to do. So the negative reciprocal square root. Yuck. It's sometimes helpful. And then just negative 1 over the y values. Sometimes that's helpful. Generally speaking, if they're going to do this on the AP exam, they're going to tell you what to do. And even more generally speaking, they're not going to do it at all. because it just takes so long to do the whole data set. If you were, like at a computer and they already had the data entered somehow, and all you had to do was tell it to re-express it in this way, then they could probably do something. All right, we will leave it at that and talk about this last page on Monday.